Thank you very much for this introduction. So, hi everyone, thank you to be here. And today I want to share with you a little bit of our experience on additive manufacturing and precisely a project I am working on, which is Additive4Rail. And this project aims to push really industrialization of additive processes in railway. So before talking about the project, I would like to present quickly the SNCF. So a big group, you have the holding on top, and I'm working at the holding, at the innovation and research department. And there are 6 subsidiaries, rail network, operating trains, logistics, trams, buses, and so on. I just wanted to focus on 2 subsidiaries, SNCF Réseau, which is the rail networks, and SNCF Voyageurs, which deals with long-distance train, high-speed trains, mass transit, maintenance, because I am working with both subsidiaries on additive manufacturing. So I'm working on train problems and also rail problems. I'm now focusing on maintenance because it was said before yesterday by Siemens, it's a really key point for railway performance. And additive manufacturing has really a role to play in maintenance to transform process in maintenance and to bring really efficiency and agility. Maintenance at SNCF, it's both on rolling stock and rail network. It's about 30% cost production for a rail service. And I just will talk about the rolling stock because in the project Additive4Rail, we are working with the rolling stock. So what do we carry out when we carry maintenance on a train? It's repairing key components, transforming the train, upgrading, overhauling, modify the train, and we have very different trains for oldies from the 80s, and some brand new trains like sort of digital natives, so different type of train, high-speed, mass transit, and different version. So you imagine it's a large amount of spare parts. I have a figure here about 200,000 of spare parts references for both the infrastructure and the rolling stock. And when we talk about spare parts, it means small series. You saw it yesterday. And we have various materials, steel, aluminum, polymers, composites. And for the rolling stock, it's about 10% of the spare part that can be transformed in additive manufacturing. So where in the rolling stocks, in train, in maintenance, where we can use additive manufacturing to transform maintenance? We can use it to reduce lead time, reduce cost, and we also have new opportunities. Reduce lead times, very, very important for us. It's the operational readiness of trains. When we have a train which is blocked in a technical center and we need a part which delivery is very long, it's very expensive for us. I have an example of a very small cap of a toilet that was needed for a high-speed train to go on rail, and the lead time was very high, and we printed it internally to really reduce lead time, and now it's on the rail, if I can say it. We print all this cap internally in a technical center. We also deal with obsolescence. Sometimes supplier doesn't exist anymore, and we always need parts for old trains. For cost, we have very few series, and as Stephanie said before, we are really focusing on digitalization storage because it's very expensive for us. And for new opportunities, we want for additive manufacturing to transform with new designs our parts to repair, also to have a solution to repair. And we have a big place for tooling because the agents needs often very special tools, and they can print it. They now have Ultimakers in technical center, and they're autonomous with this. Just 2 examples on how we can cut lead time and costs with additive manufacturing. First, on the high-speed train, we have a part on the door, then we divide it by 20 the lead time, thanks to powder bed fusion technology. Second one, at the opposite, very old train, and it was a matter of supplier, very hard to find a supplier for very small plastic parts, and FDM give us a very competitive cost. I've presented the opportunities. I will go now on the limits. We have identified several limits. From a technical, numerical point of view, we have a lack internally of 3D data. Actually, all our spare parts are in 2D, and right now we can now not put 2D drawings directly in a machine. It will be very easy for us if we can do this, but we can't, actually. We see that the numerical chain from the design to the final part is still weak. If we go on a material point of view, there's a lack of data available from a user point of view of material and processes, and a big point for us, it's the polymers, because we have a flame retardant requirement, and today on the market, there is only one material that we can use, which is ULTEM, and it's very expensive. If we now go from industrial point of view, additive manufacturing is still very expensive for railway, and we have large parts, and we are still restricted from the part dimensions. And to finish, we need railway standards, and we also, SNCF, if we want to include additive manufacturing in our supply chain, we need to totally rethink the supply chain from engineering to purchasing. So now you have the frame, and I will present the project Additive4Rail. So Additive4Rail, it's a research project funded by France, a 4-year project. It has begun 1 year ago with 4 partners, SNCF, no need to present it, École Centrale Nantes, which is a university focusing on material and processes, and has real expertise on WAM. 4D Pioneers startup, which provide materials and machine, and for the project they're focusing on polymers, and VLM Robotics, who are a supplier of 4D cell, and here they are on the XXL metal parts. The objective of the project is to ramp up industrialization of additive technology, and also to optimize train maintenance and lower cost. And the big idea is to combine research and industrialization to tackle the limit I've just said before. Here you have the structure of the project. We go from numerization to certification, and we are working on techno bricks, the numerical chain. We are also developing processes and techno bricks on processes and new materials from metallic composites and polymers. For metal, we are mostly focusing on WAM, and for polymers, more on FFF. We also included the industrialization because for us, we do research, but we also really need to implement in a plant, in a technical center. And to finish, we also look at the certification, and the certification at the very beginning of the project, because it's not at the end of the project we say, oh, what we're going to do with this part we have just built. And the project is based on 300 components we have identified which can be produced by additive manufacturing. So we have a sort of library that every partner can use to produce parts. I will now go on the challenges for WAM for us. The big idea is to produce large parts, to integrate an industrial know-how at SNCF, but also to grow the know-how of the partners, to qualify parts for rolling stocks, and to validate components on train. And how we will do this? We have already set up a WAM cell in the maintenance center, and this WAM cell, which is a small WAM cell, we will improve it, upgrade it during the project with the partners. And something else, and this was said a lot of time before, we are relying on a strong collaboration between partner and an industrial and research collaboration, which is very important and very rich. Now I'm focusing on the polymer and elastomers challenges. On the left, you have an idea of the cost that we have in railway regarding with aviation. So we are very low, and we have a lot of pressure. And the idea with the project is to enlarge the flame retardant material portfolio, because as I said before, we only have one material, and we want material that meet the railway cost and improve also the use of materials. And how we will do this? We will develop new materials during the project, qualify also new materials from commercials, and once again, rely on collaboration. To continue, I will make a quick focus on what we did on WAM. Here you have the cell we have installed, we have set up in the maintenance center in Saintes, which is near Bordeaux, in the west of France. So we have hardware and software, and the engineers working there are operational. They are building parts, and I'm going to show you some parts. And so this little cell is a toy, and then we will industrialize it. And here you have the first part. So two parts we've just produced in a technical center. And the idea is, okay, we are producing walls because we need characterization and so on to know how the process is responding. But we also need parts and to know how we will qualify these parts, because at SNCF we are qualifying ourselves. So we have a wall certification program, work in progress. Here you have two shafts we produced about this size, about 60 kilograms, and now it's how we will put this, the question is how we will put this parts on a train. To finish on Additive4Rail, for us it's a great opportunity and sort of lab, a place to experiment new technologies. I talked about WAM and FFF, but we are looking also at composites, at rapid casting, so we are really experimenting. Second point, the numerical chain for us, it's an asset for industrialization, and we need also for qualification. And to finish, this project for us aims to prepare the future of our maintenance and to prepare how to transform the supply chain. Thank you very much